Welcome back to the third afternoon of the Great Apes Summit. Hope you had a nice lunch, that you've come back from that gorgeous exterior, that the sun and the scenery is a testament to your devotion to great apes, so thank you very much. You lose a lot of delegates at conventions after lunches, so thank you. I can now turn the session over to this session on technology, which really will pave the way for a lot of the future work we do. Will certainly play a role in the work that we do, and the panelists up here will give us some ideas and some inspiration for the future. I'd like to pass it over now to the moderator, Vanessa Berlowitz from BBC. Thank you.
I'm an executive producer at BBC Natural History Unit, and I've been working there for over 20 years, making shows like Planet Earth and Frozen Planet, and just embarking on a new series called One Planet, which is going to hopefully document and explain the value of biodiversity, something I know that's very dear to all of your hearts. I'm delighted to be asked to moderate this panel today. Very interested and excited by the approach of the Great Apes Summit, that aims to bring together sometimes disparate groups that all share a common goal of wanting to conserve endangered species, specifically great apes. So given that the film festival has kicked off, I'm guessing we have a mix of wildlife filmmakers in the room, as well as conservation biologists and conservation activists. And I'd just like to see a show of hands of the filmmakers. Great. And conservationists? In the majority. Okay, that's helpful. I think what's really interesting about this panel is that advances in technology are really relevant to both of these groups. Just as they help filmmakers to keep improving the way we document and deliver the natural world to our audiences, these advances are also transforming the way that scientists conserve it with new ways to monitor species, manage protected areas, and also, vitally, to get the public involved. What's more, we're all utilising the same types of technologies, as I've been hearing from our speakers. As a wildlife filmmaker, I've personally benefited immensely from the breakthroughs in technologies made by biologists in the field. I can barely name a shoot where we haven't depended on your data to help us find and film animals. Initially, this data was obtained on foot, then with telemetry, more recently satellite tagging. And as a sign of the changing times, many of the scientists that we work with are collecting data that is as much to inform conservation as it is to add to the understanding of the species. And for example, the camera traps that were put out to work out snow leopard range in the Himalayas, as compared to the area that was actually protected, were a vital tool in helping us capture the snow leopard sequence that was in Planet Earth. So these are probably the kinds of technologies that many of you are familiar with. But today is about highlighting work that is being done at the cutting edge. The question we are asking is whether these technologies can help scale up conservation efforts around our critically endangered great apes and influence decisions that really will make a difference. So without further ado, I was going to give you an overview of the key areas, but I think it's actually much more interesting to cut straight to the chase and get to our speakers. We met up and started to have an absolutely fantastic discussion where we realized there were so many overlaps in all of our works, including mine with theirs and theirs with each other. But what I've asked them to do today is to try and explain their technology as simply as possible. After all, it's not the technology, but what they're doing with it that is interesting. So please scream out and interrupt if you're lost, because if you are, chances are others too, and I certainly will be harassing them to keep it simple. We're going to hear amazing examples of where their technology is working, and they're really starting to get results that are clearly benefiting great apes. I then asked them to think about how vital they see this technology being for the future of conservation biology. Now, the thing I'd like to urge the filmmakers to do is to really focus on the fact that we're converging on the same technologies. So, can we share resources? Can we share R&D? And also in response to Ian Redmond's call to action earlier, which I thought was very powerful, we need to work harder to give the context of these fantastic creatures that we're so desperate to film. And I know I'm going to be badgering all of these individuals afterwards, asking for help to try and get the amazing images that we need to make the shows. But, are there clever ways that we can integrate the stories and the amazing work that these individuals are doing so that we can really show the context and the struggles that these animals are facing? And as for the conservation biologists amongst the audience, I urge them to think about, could they benefit from applying some of these technologies to their projects? And if so, any thoughts or comments? And I'm sure our speakers would be very interested to hear about that. So I guess it's all about scaling up conservation efforts, and that's what technology does. And we need to do that fast for great apes. If we don't pull together, we're all just playing with toys. So I urge you to think hard, and then we can make a difference. I'm going to come to James Robbins first, who's a primate conservationist monitoring post-release orphaned orangutans at the Tabin Wildlife Reserve in Borneo. And he's using implanted radio telemetry transmitters. Round of applause, please.
Thank you, Vanessa. Good afternoon, everyone. My name's James Robbins. As Vanessa said, I'm the post-release monitoring manager for a very small rehabilitation project in Sabah, which is in northeastern Borneo. Now, I'm probably the anomaly in this panel session this afternoon because I'm not, by no means did I actually develop this technology. I'm just an end user. And in fact, our post-release monitoring project was one of the first to adopt this technology when it first came about in 2009, 2010. So if you just take a look at this first cover slide, this is actually what I'm going to be talking about today. These are small, miniaturized VHF radio transmitters, and essentially they only act as VHF beacons, so the technology is not particularly advanced, but it has actually revolutionized the way that we're able to collect data on rehabilitated and released orangutans. So if I move on to my first slide, I'm just going to give a little bit of background. Prior to the development of this particular technology, there were really no effective ways to monitor released orangutans. Many projects would tend to just rely on chance sightings at feeding platforms or whatever else the setup was within their release sites. As a result, there was been somewhat of a lack of systematic data collection. Okay? And the main reason for this was the fact that radio collars have traditionally been thought to be unsuitable for orangutans. Orangutans have very small heads, quite thick necks. The males have obviously large throat sacs and a lot of soft tissue in that area. So attachment devices around the necks have always thought to be unsuitable for orangs. Another thing I just want to point out, it's not necessarily directly related to the technology, but I think it's also relevant. Post-release monitoring is very, very expensive. It's very difficult. It can be often hard to find long-term funding for post-release monitoring. And it's also difficult for a variety of other reasons, including the ranging habits of orangutans, the terrain at release sites. And I kind of think there's always been a bit of an assumption that the job is done once you release an orangutan. We've successfully released an orangutan. Really? Well, how did you know if you didn't actually conduct long-term, thorough monitoring? The result of all of this was that there has been very little published information on the diet, the feeding behavior of orangs, mortality, social-human interaction, and of course, their ranging. And also, constituent to this, it's possible that hundreds of reintroduced orangutans died unaided, and we certainly missed many opportunities to learn from people's successes and failures in this regard. So the breakthrough really came with this technology back in 2009 when Dr. Chris Walzer from the Research Institute of Wildlife Ecology at the University of Vienna developed these, he actually managed to miniaturize these VHF transmitters. They're surgically implanted. I'll go into the details in a moment. But the first, just to give a bit of the timeline, the first 3 rehabilitant orangutans were implanted in September 2009, and then they were released as part of my project in Tabin Wildlife Reserve. And since then, all but one of the main orangutan reintroduction projects have adopted this technology, and there have been a total of 180 surgeries. So the uptake has been quite huge since it came on the scene. So a little bit about the specification here. Fans of Blue Peter, here's one I made earlier, guys, for all the Brits. As you can see, it's very, very small. The electronic circuit is housed in a ceramic casing. I'd pass it around, but it'll probably take about a year to get back to me. The surgeries are very simple procedures, actually. They're implanted into a subcutaneous pouch in the dorsal neck area, just either side of the spinal column. The mean surgical duration, I've been collecting data on from all of the projects that have been using this technology so far, and the average surgery time is around about 23 minutes. It's quite a simple procedure, and that's from first incision to actually closing the wound. And the average time it takes for the wound to heal comes out at around about 11 days, but the range ranges from about 4 days up to about 6 weeks. If the orangutan picks the wound, it can take a while for it to heal, and then obviously it's not ideal that then you have to cage restrain them, keep them caged up while they're healing. Yeah, one of the key benefits of implanted radiotelemetry is it has a programmable transmission schedule. So for example, in Tabin, I've asked the developers to transmit in 2 different time windows, for them to come on at 5:30 in the morning, and then to go off at around about 11:30. And then just in case we lose the orangutan in the middle part of the day, particularly in Tabin, we get a lot of rain in the middle part of the day, just in case that happens, for it to transmit for an extra 2 hours. So that's 8 hours per day, and the estimated battery life based on that particular schedule comes out at around about 3 years. And the main uses, obviously, it enables both triangulation for remote monitoring of ranging, or homing if you want to be out there collecting direct observational behavioral data, which is what we've been lacking all these years. So that's essentially what I've been using it for. The maximum distance of these, people report getting signals from anything between 1.5 to 2 kilometers, but it's very, very dependent on your position relative to the orangutan and the land mass in between. Another benefit, they're far cheaper than radio collars, although functionality is significantly less. As I said, these are just very basic. They're just VHF beacons, essentially. Okay, here's a nice bit of video with one of my orangs, one of my girls in Tabin. Her name's Otan. As you can see, it really has very little effect on the orang. It's quite visible, but it doesn't really affect her feeding or locomotion or anything along those lines. Okay, so what are the conservation and potential welfare implications of this technology? Well, I think the main one is the fact that we're now able to collect data a lot more easily. There's now a growing body of data on the adaptation of rehabilitant orangutans. And with this data, it's hoped that we're going to be able to be in a position to improve the work being done to prepare the candidates at the pre-release stage, to select the right candidates in the first place. And let's not forget that the orangutan population, the rehab orang population, is growing and growing and growing, particularly down south of the border, down in Kalimantan and over in Sumatra. It's also going to inform a decision-making process on release site suitability based on the information and the adaptation of the orangs that we're now collecting data on. And it's also going to enable regular health monitoring of every individual that we released. It's going to boost individual welfare. And I think if we're really serious about creating self-sustaining orangutan rehabilitant populations in areas where there's no wild populations, I think, certainly based on what I've seen in Tabin, we're going to need to have a more proactive approach in terms of intervening when necessary. I was interested to see that Martha was in the extreme conservation session. I would, presumably, I kind of fall into a similar category because we intervene when necessary. Okay, so some of the costs and limitations of this technology, and these are really key points. It's an invasive surgery. Okay, we have to cut the orang open in order to get this in there. And there's definitely an ethical dimension with this particular technology, and I think you do well to remember that you can always have possible donor resistance when you conduct procedures of this kind. Now, with the surgery, there's numerous inherent and unknown risks. Obviously, all of the animals, all the focal animals need to go under anesthesia. There's a risk of infection in the wound healing process, of course. And one of the key points, one of the key issues that we've been facing recently with these implants, we've had numerous cracked casings. And the casings are just made out of, they're ceramic casings. And for whatever reason, a lot of them have been cracking out in the field. And this could obviously lead to leaking contents, tissue necrosis, things like that. Just take you through some of the photos here. Sorry. This was actually removed from one of our orangutans, Anakara, by my colleague Nigel there. Another orangutan had actually attacked her, and she bit more or less straight through the transmitter. So we need to be aware of that. And whether the fact that the transmitter was so visible, maybe that could have been one of the determining factors in that particular orangutan going for that area, possibly. They have a really high premature failure rate, and it's just simply not good enough. And this is, I've been collecting data from all of the projects that have been using this so far, and this is a confirmed figure, the 18% confirmed. But that's, I would imagine it's going to be a fair bit higher than that, because a lot of the orangutans, particularly in some of the projects down in Indonesia, where they're conducting larger group releases, they probably most likely haven't seen the orangutans for a good few months. So this is just confirmed. I would imagine the figure will probably be closer to around about 1 in 3 would fail at this stage. Now, what do you do when they do fail? Do you recapture the orangutan, which is slowly learning how to be a wild orangutan? Do you bring it back in, have a surgery, and replace the faulty implant with another implant that could well fail again? And obviously, bear in mind the cost of these, 370 euros, 311 pounds, or around about 500 bucks a go. So, given that the technology is still a little bit dodgy, that might not necessarily be a very good investment. The size of the transmitters and the fact that it has no external antenna is meaning that we're getting very limited range on these. The average transmissions, when you conduct standardized tests at 50-meter intervals, come out around about 300 meters on the flat. That's actually from Tabin, from my release site, where it's particularly hilly. I think you probably get a fair bit further if you had a flatter release site. So I actually met with a couple of technicians, because as I said, I'm not the technician. I'm not really capable of creating this technology myself. So I met with a couple of people recently just to get their ideas on some potential innovations that I thought could be useful for us. So the first thing I mentioned was the possibility of having a remote connection. So for example, if we decided we didn't need to follow a particular individual for a while, could we then remotely switch off the battery so that would ultimately extend the battery life further? And they told me that the cost of constantly needing to be on to detect any remote signals would most likely outweigh the benefits of, outweigh the possible battery savings. And then I talked about an alternative implantation site, because I think one of the reasons why we're actually getting a lot of cracked casings in these implants is because of where they are. You saw the video, they're quite visible, and I can't speak for the other projects, but a lot of my orangs in Tabin, they like to roly-poly, particularly down really, really steep terrain. It's crazy. You just watch them, it's like watching a cannonball go down a hill. And I think, given that particular location on the back of the neck, it's likely that if they're rolling on a rock or a buttress of a tree or something, it's very likely that could then crack one of the casings. So we talked about abdominal implants, because I'm aware that there's some projects that use abdominal implants. But apparently they tend to migrate within the body of the animal, and there can be even more complications with the implantation site, particularly if it's in that particular area. And the lack of functionality, they are very basic. It's still just VHF technology we're using, so can we incorporate GPS to this? One of the issues, the technicians said that GPS implants just simply wouldn't be possible with body fluids and fat and skin affecting the range of this. However, the guys at FUI, at the University of Vienna, recently tested a subcutaneous implant. They said it worked well, but they're still having a lot of problems with with downloading the data and getting significant battery time for extended use. Okay, and this I think would be particularly useful for us who are conducting releases, to have some sort of onboard sensor. I went really long with this. I was talking about, can we measure ketones in the blood? Can we get body fat percentage? It was kind of ridiculous, but I thought I'd ask anyway. And I think it's perfectly feasible for us to incorporate activity mortality sensors within these implants, so that when the movement sensor detects no movement for a pre-programmed period of time, it would change the pulse rate to indicate a change in behavior. And then that would obviously be up to probably the post-release monitoring manager, the person that knows these animals individually, to judge what would be an abnormal period of time for resting for a particular individual. And then that would potentially help people who are doing larger group releases to be able to identify, okay, that's on a different pulse rate, let's go and see him or her, maybe they're in trouble. Okay, so just to bring it to a close, VHF implants remain the only option for locating released orangs, but can certainly be considered for all other great ape species. And we were at the PASA reintroduction workshop last week, and I spoke to Tony King, who's just implanted 3 of his gorillas with these implants as well. So it'd be interesting to see whether he's comes across similar issues that we have. I think, based on my experience, it's vital for release sites to have extensive trail systems in place prior to release to facilitate tracking, as we lost our orangs, even with the implants, many, many times. And given that once the post-release stage is so difficult for these animals, they often go off exploring over crazy areas, and I think that's definitely worth considering. So the functionality is limited by its current size, but there is significant, albeit relatively untested, potential for miniaturized additions, and I'm talking here about adding some sort of GPS capability, and as I said earlier, the activity sensors. A key point here, I think, it really needs a lot more investment and input from surgeons, engineers, technicians, and field researchers, everyone kind of pulling together and investigating how we can make these things a lot better. And another point, it was really interesting, I refer back to the meeting we had last week in Chester in the UK. I actually asked everyone there, has anyone actually tried to fit a collar to an orangutan? I think it's just essentially conventional wisdom that these things wouldn't work, they'd easily get them off. And I couldn't find anyone that actually had seen what actually plays out once you attempt it. So I think we need to reassess the feasibility of radio collars, certainly, or if not, anklets or bracelets. And we can certainly share experience with other projects. And these are some of the project collaborators, and these are my boys in the field. And thank you very much.
Thank you, James. Our next speaker is Serge Wich, and he studied Bornean and Sumatran primates for 20 years, with a special focus on orangutans. He's a professor of primate biology at Liverpool John Moores University in the UK, chairs GRASP, and is co-founder of the non-profit conservationdrones.org. And I'm very interested to talk to you more about drones, so more later. Thank you. Round of applause, please.
Thank you. I'm also going to stand up because it's just nice. Oh, we're starting with that slide. So I'm going to talk about a project I'm doing with Lillian from the ETH in Switzerland. And it's conservation drones. So what we do is we build small unmanned planes and we fly them over forests. And here on this slide, you see one of these drones. And up there is an orangutan in a palm tree. Not an oil palm tree, but a normal palm tree that you see in the forests. So we all know that this is a problem. We lose habitat, and at the same time, we don't then know where orangutans are, whether they are still in their habitat or not because of hunting, and where they are in these disturbed habitats. So what we traditionally do, we go out on foot for a long time, we walk through the water and we count the nests that orangutans make, like other apes. They make a nest every night, and that gives us an idea of where they are and how many of them are. And this is great work, I love it, but it's a little bit slow, and it can't keep up with the changing facts on the ground. So we're often too late once we're in there. At the same time, we try to always monitor habitat loss. We do that through the use of satellite images, which works really well, but often it doesn't give you the resolution that you need or the frequency and time that you need to make interventions when that's necessary or to go to areas where that's necessary. So when Lillian and I were discussing this, we thought, what if we could just fly a little drone, a little plane with a camera over a forest and make pictures of the orangutans or their nests. So we looked into doing this, and I'll talk a little bit more about the technology later. But we basically made a very simple system with an autopilot in it, etc., and we took it out to Sumatra to test it, and it worked really quite well. So this is some of the first footage we took over more than a year ago in an area in the Gunung National Park, where you see the forest and the edge of the forest with plantation development there and some fires. And these simple drone systems can give you quite detailed, high-resolution information on what's happening there, and you can basically fly them anytime you want. So it is really useful for people in the field to get this information, because normally we have to go on foot and to all these locations, and that's just more difficult. So I'll stop it because it will go in for a while. So how do these systems work? Well, they're basically very simple. It's a model aircraft that you can buy from any radio control shop, an autopilot by company 3DR in the US, and any payload you want to put in it, whether it's a GoPro camera, which we really like and put in these a lot, or another still camera, and a piece of software that's just free software that allows you to plan these missions. You can plan the missions by basically clicking on your favorite satellite layer, Google layer, Bing, whatever works well for your area, and you can do simple missions or very complicated missions or mapping missions or patrol forest boundary missions, and you load this up to the plane, and then you fly the plane. It flies itself and it lands itself, so you don't really need to learn how to pilot the plane, which is good because flying a plane is quite difficult. So then what can you get from these planes in terms of footage? Well, you can see orangutan nests, which is really good for us because that was why we developed it in the first place. So we can now use these systems to find out where orangutans are, which is extremely helpful to cover some of these large areas where they occur. We can do the same with chimpanzees. We've tested this in Gabon and it works. So we can find chimpanzees in areas as well. We can find orangutans in trees if you're really lucky. This happened on the first day that we flew the first drone out there, which was, yeah, really, really lucky, but it helped to give us a bit of confidence in that this really works well. You can take pictures of other animals, elephants, forest buffaloes, for people that work in marine systems, turtles on the beach, their tracks, their nests, you can see those as well. Rhinos in Chitwan, etc. There's lots of opportunities for different species to use these techniques. You can get down to tree species identification. This is from Gabon. These are species in forests where chimps occur. So you can get down to very high resolution images and use it for some basic inventory of trees in certain habitats when you want to, for instance, try to find out whether this is a good site for reintroduction of species. You can look at agricultural expansion and count palm oil trees. You can look at forest encroachment on the edges of forests, so you can see the planks that were recently from a tree logged there. So it gives you a lot of information on what's happening on the boundary of protected areas, which is very useful for conservation people. You can stitch all these photos together from drones and get these mosaics. You can basically geo-reference these and use them in any GIS program. So all of a sudden you have a very high resolution photo layer on top of a not so high resolution, for instance, Landsat layer. So Landsat, for instance, is freely available satellite images with about 30 meters per pixel. And the cameras on the UAV give you about 3 centimeters per pixel. So it's a huge difference. So you can see a lot more with these kind of systems. You can mosaic these together, as I said, and then if you do a little bit of playing around, you can make 3-dimensional representations, which is really just a lot of fun. And it's also useful because you can look at gaps in the forest and in habitats. So it's another way to visualize habitat which is useful for conservation people. As I said, you can detect fires, which is useful as well if you want to know where forest fires are, but also if you want to know where people are in the forest that are drying bushmeat. We tested that, and you can see these fire plumes above the canopy. So it's very useful, and you can do this with one of the fixed-wing planes or with quadcopters. Quadcopters are these small copters that you can launch from a logging road, get your eyes above the forest canopy, turn 360 degrees around, know where forest fires are or fires, and you can send people into the compass directions where the fires are. So it's very helpful to make patrols more effective. At the moment, we're working on a lot of new development in terms of models. We're moving towards these wing systems because they're quite robust. So that's good because we don't always have nice British lawns to land our drones on. So we need something that's very robust. So this is one of the models that we're testing out now. It's a small drone called Caparinia. And it's very simple to launch, and it flies. This is in Switzerland 2 weeks ago. And it lands automatically. Here you have a pretty lawn, so that's good. But you don't always have these. But these wings are a lot more robust, so it's potentially very useful. What we're also doing is realizing that we are getting a lot of photos and a lot of data. If we have to go through all those data by hand to detect nests or other objects, it's going to be very cumbersome. So we're working with computer vision people at the ETH in Zurich to try to automate this for us. And it's going very well. So we can just feed in all the photos and they will detect the nests within a certain probability. So that's very useful for us. We're of course dreaming on what we could do with this. We would love to have camera traps in the forest in remote areas, and we would fly the drone over it to just upload the pictures and then fly the drone back. So you don't actually have to go to remote areas where camera traps are. The same thing to help James with his orangutans in the forest. What if we could just fly these drones over the forest and collect the information on where the orangutans are? That would be very useful. We're working on this with people that work on orangutans, but also other species, because it would be useful. Another thing which we would love to do is to drop in small, simple spy mic recorders in the forest that would be usable for quick biodiversity surveys. We throw them in there, they would beam up information for or record information for about a week. We would fly over again and obtain the information, upload it to the drone, and then get it back. And we would have a some quick data on what primates are there, what birds are there, what kind of grasshoppers might be there. There's lots of people that have asked about this as well. So that's something we're working on. So we're really keen to try to help bring this technology to people in Great Ape countries that need it. And of course, it's important to realize that there's limitations to this. It's useful for determining distribution and potentially abundance of apes, monitoring habitats and mapping habitats, and detecting poaching activities. But at the same time, you still need the people on the ground and law enforcement to follow up on this information and to actually be able to use it, because drones collect data. They don't actually do conservation work. They don't solve the problem, but they can be a tool in trying to help solve the problem. So that's it. Thank you.
Thank you. Thank you, Serge. And next we have Rich Bergl, who's the Curator of Conservation and Research at North Carolina Zoo. He's conducted conservation research in Africa for over 15 years with a focus on innovative approaches to studying and monitoring the endangered cross-river gorilla.
But a little bit of context first. I know we've talked about a lot of these issues already, but in most of Central and West Africa, the primary threat to apes is poaching. And not to start on a down note, but we're really losing this battle. And so we need some pretty fundamental changes in how conservation is conducted. Things like education and outreach, political will, increasing political will for conservation, economic benefits to people living around ape range areas are all things that have to be done and done well in order for ape conservation to be successful in the long term. But as some people have already mentioned, if we wait for these things, which are medium to long-term solutions, to take effect, we're not going to have much left to conserve. So we need to stop poaching, and in order to do that, we need to make conservation law enforcement more effective. There's a variety of different things that are needed to do that. Some of those were talked about already this morning in the extreme conservation session. But resources that are commensurate to the threat faced by apes are critical. This is, of course, money, but it's also things like training and equipment and all the things that rangers need to do what is actually a very difficult job. But we also need data in order to make conservation more effective. And this isn't data for research purposes, this isn't data for publishing papers, this is data to inform protection so that protection can be done in the most effective way possible. And then also, as I think Martha mentioned this morning, data to check to see if the interventions that we're making are actually having the outcome that we hope they are. So, starting about 2 years ago, a consortium of organizations, including the North Carolina Zoo, but also some much larger conservation organizations, came together to create a new tool for increasing the effectiveness of conservation law enforcement. And this is something that we refer to as SMART, or the Spatial Monitoring and Reporting Tool. This is basically a software that has grown out of a relatively long history, for software anyway, of law enforcement monitoring packages like MIST and CyberTracker, which some of you may be familiar with. And lessons learned from those softwares was used to inform the development of SMART. SMART is actually a pretty extensive software. We spend over a week training people how to use it, so I can't go through all the details. But just basically how SMART works is it's based on data collected in the field by rangers on the ground. At present, they collect it on paper data sheets with a standard GPS, but that's going to change in the near future. They bring the data back, they debrief with their manager or whoever's in charge of the protected area. Data go into the SMART database, and then SMART more or less automates the analysis and reporting of data in order to inform future conservation actions and to tell patrols where to go, to determine where threats are most intense, and to evaluate overall effectiveness. So a couple of key things about SMART are that, number one, it is designed to be a site-based tool. So this is something that operates at the level of the protected area. It is not designed to collect data for scientists in other countries to then analyze and send back to the protected area 6 months later. It's something that's designed to happen very rapidly. And it's designed to be user-friendly. A lot of the places where this is designed to be deployed have relatively low levels of technical capacity, so it has to be usable for the people on the ground. SMART puts the power of maps in the hands of people who are directly responsible for doing wildlife and ape conservation. Maps are a very powerful tool for very quickly visualizing sophisticated and a lot of information. So in the case of these maps here, this can help us identify parts of a protected area that aren't getting proper patrol coverage. SMART is also about accountability and making sure that the people who are responsible for doing conservation are doing their jobs. It allows you to see where did patrols go. So if you assign your patrol to go from headquarters along this road towards the edge of the reserve, did they actually do that? And then over longer periods of time, what is the patrol effort, and why, in the case of this graph, why is the patrol effort going down? So it allows you to flag problems relatively quickly and deal with them. As I said before, these data are only really useful for conservation if they can be accessed rapidly. So SMART more or less automates the process of extracting data and taking information out of those data in order to make them actionable. Basically, once the data go into the SMART system, you more or less push a button and the report is generated, which tells you, in this case, where the patrol went, how many patrols were foot patrols, how many were vehicle patrols, various different statistics about the patrols, and a host of other data as well. Another development, so in addition to, right now SMART is paper-based, but one of the things that is, I think, going to revolutionize conservation law enforcement, well, it already is revolutionizing conservation law enforcement, is the development and the proliferation of mobile devices, and particularly how increasingly sophisticated they're becoming. So right now, and for over a decade now, the way that a lot of field work works is that people go out with a data sheet and a regular standard GPS unit. They write it down, they write down the GPS data, they take it back to camp, they enter it into a computer, and that takes quite a long time. Nowadays, you can collect those data with a handheld device. Another big development is the availability of low, and I say low-ish cost rugged devices. That's things like this Trimble device. In the presentation from JGI last night, I was really impressed by a lot of what they were doing. But thinking about those guys carrying very nice, shiny tablets out in the fields, I know if it was the guys that I work with, they wouldn't last very long. So these are really tough devices designed to stand up to the rigors of a tropical environment and rangers who perhaps aren't as careful with electronics as we are. The software that we use for doing field data collection also has to be easily used by the people who are responsible for collecting these information. Often these people don't have a lot of technical training. So we use, at the moment, a software called CyberTracker, which was originally, originally designed for illiterate Kung San Bushmen in South Africa. It can be entirely icon-based, so you can enter in all your data just by tapping on pictures, or if you want to enter in more sophisticated data, in this case, putting in a gorilla nest, you can do that. Mobile devices and the associated software also allow you to have much greater navigation capabilities in the field. A lot of the places where we work, there are not good maps, and it's very difficult to know where you are. You can have a moving map in these devices so you can see where you are. You can follow a mission plan from point A to point B to point C. And so that is a real revolutionary development for this kind of work. Again, as with when I was talking about smart, mobile devices increase accountability. So the software, the CyberTracker software that we use currently in Nigeria and Cameroon, automatically collects a GPS point for that device every 5 minutes, even if you turn it off. If you turn it off, it wakes itself up every 5 minutes and collects a GPS point. So you know exactly where the rangers and the patrol team were at every 5 minutes over the course of their patrol. We're also thinking about now combining this with the camera capabilities of mobile devices. So not only every 5 minutes do you have a position, but you can also take a picture of your patrol team every hour or 2 hours just to make sure that everybody who was there, who was supposed to be there, was actually there. And just a quick one slide of a case study. We've had this type of law enforcement monitoring software deployed in Nigeria and Cameroon since 2009. These are data from one site, the Mbe Mountains in Nigeria, which is a really important site for cross-river gorillas. And over the 4 years that we've been active, we've been able to document, and this is not just due to the software, there's a ranger program that is behind this, but we've been able to document a massive decrease in the number of snares that are being removed, a big decrease in the number of gunshots, a big decrease in the number of empty cartridges, and more or less, there's a bit of a blip at the end of 2012, but more or less increasing and then stabilizing number of patrol days per year. So it's a good way to check, are you actually having the outcomes that you're hoping to have? Even though the software and the hardware are very sophisticated, they're really still in their infancy. What we want to do next is to develop the capability for real-time data transmission from guys in the field back to headquarters. Right now, you have to carry the mobile device back to the headquarters, plug it in, and the data get downloaded into the database. We'd like to have this happening in real time so that headquarters can know where rangers are all the time and know what they're encountering while they're out in the field. We also want to be able to integrate additional types of data beyond just the data the things that the rangers are seeing while they're in the field. Data from things like autonomous recording units. These are being field tested at a few places around Africa right now, particularly Korup National Park. These devices that are hung up in the trees can be used to triangulate the location of gunshots. So if we had those data feeding into SMART, that would obviously be another way that we can go out and pinpoint areas that need protection. Camera traps also, Serge mentioned this. These are another way to capture data about illegal activity or about wildlife and to feed back into that law enforcement monitoring system. And high-resolution satellite imagery, which again gives us the ability to better navigate in the field and better understand the landscape dynamics present at our sites. In the long term, though, what we really need to do is emulate more what the modern militaries around the world are doing to have one single integrated command, communications, and control system so that it isn't just a one-way flow of data from the guys in the field back to headquarters, and then some analysis is done, and then they that reinforms the patrol strategy. We need to have all of this happening more or less in real time, so that data can go from the field to headquarters, headquarters can communicate back to the field, guys in the field can be receiving data from drones, tasking drones to go and check out areas that they are potentially going to go on patrolling on, and headquarters can respond to what's happening in the field to send out additional rangers or call other agencies or whatever is necessary. So in order for conservation law enforcement to be the most effective in the long term, I think we are going to have to move towards what is actually quite a sophisticated system in order to really accomplish our ape conservation goals. Thank you.
Thank you, Rich. And our last speaker is Lillian Pintea of the Jane Goodall Institute. I'll let you introduce yourself.
Thank you. Well, I'll focus my presentation on similar topics, but mostly working outside protected areas and national parks and with communities. So in this way, it's very nicely complementing what we just heard. I was born and grew up in Moldova, in Eastern Europe, and on numerous trips, camping trips with my dad, fall in love with nature, and in 1991, started using satellite imagery and remote sensing and GIS. But it took me 15 years until Google Earth came out, and I was able to zoom in those places, which I love so much, and see how it looks from above. And it took more than that. This morning, actually, I checked it out. And I found out that now I can look at the place which I was born and fished in these rivers at high-resolution imagery. And, you know, it's a black and white picture, but for me, this is very real. It's a lot of colors, and I remember the sounds and smells of the flowers, and I can experience again those memories from my childhood. And all of you now can use platforms right now like Google Earth and zoom in some of these places which are special for you. So when we applied high-resolution imagery back in around Gombe, we didn't forget about that there is much more behind the imagery than just the picture. We did participatory mapping. We mapped the indigenous knowledge of places, of sacred sites. We used GIS to overlay all this and do also different prediction modeling. But then we used simple ways of mapping and planning for the sites with the local communities. As a result, this is Gombe National Park. This is the conservation goal, the target, which we wanted to achieve based on a conservation action plan. This is the village boundaries, and each village independently set up a land use plan, which has this in green village forest reserves around the Gombe National Park. So it's a fantastic result in a very difficult place to work with one of the highest increase in population growth in the world at 4.8% per year. Of course, this is a plan. The plan was done in 2005, and we have been using high-resolution imagery to see what's happening, what is the implementation. We have been working with this community to build their capacity to implement these plans. So this is how a village forest reserve looks like when it was created in 2005. This image was taken with Iconos satellite image. And by the way, I specifically decided to show you what is available publicly in Google Earth, so you can see it yourself, avoiding all the fancy GIS software and desktops and devices. So here, what the different satellite image took in 2005 in June, so it's QuickBird imagery. It's pretty much very similar. And this is how it looked now in 2013 in June. Big difference. We can go around. Again, this is Kagunga Village Forest Reserve. This is how it looked in 2005. And this is how it looks now in 2013. We can go closer to Gombe, which is in the north. This is Kizuka Stream, Mtanga Village, how it looked in 2005. You can see the erosion of the riverbed, which was as a result of a flash flood. And this is how it looks now. You also can see increase in threats. For example, that road on the right, it's a big road now coming towards Mtanga. But you also can see reforestation happening in village forest reserves. So, because we have been, since 2009, introducing mobile technology to the communities, we can overlay now their perspectives and their data to this imagery as well. And I guess I have to come back to the point about ruggedness of devices. And GGI approach always have been very practical. We have 1,000 tablets donated recently by Google, for example, at no cost. So we always looking for opportunities to leverage whatever in-kind contributions we can in order to achieve the goal. And these devices, you'll be surprised, once these devices are given to the village government, which then are passed on to the village forest monitor, which they hire. And you'll be surprised how careful they are once they have a proper pelican case, whatever, and how proud they are about these devices. But I totally agree that the future, and the near future, is in implementing more and more rugged devices. It's just they're expensive. So this is the same plan overlaid with the ODK data collected by the communities. And the important thing about the systems we're implementing is that it's connected to the cloud. The moment when they downloading the data available in the cloud and are open to everybody who, to use it. For example, this is a dynamic map which we developed in mind with the villagers that when they have access maybe to an internet cafe, to the internet, they can able to actually very simply see their own data which they just collected. You can also do more scientific analysis. This is, for example, 5 villages with different data collected over a year. You can look at the patrol length. You can calculate and then encounter rate, for example, of threats per kilometer patrol. This is important information. Now you can compare between different villages, between different time intervals. But I'm always intrigued what lies behind those pictures. We have thousands and thousands of pictures, and often the stories are locked in those pictures. The data are very important. But for example, this is a bullet cartridge, which was collected by Forest Monitor in Kigali. And I asked him, okay, why you collected? Well, it's a threat. It was on the list in the form I collected. But the reason why he collected as well was because he said, I never seen this before. But because I guess forest is coming back in our village, we have more wildlife moving in. And it looks like poachers came in as well. So now we have a new threat. So I took this picture to show my village government that we have a new threat to think about, to deal with. Another was it's a sacred site. I asked him, why did he choose this picture? Well, there's a form on the smartphone and tablet which they can collect any information they want, which they think it's important. And because he knows that other villages collected sacred sites, he went to an elder and asked, do we have such sites on our village land? And the elder pointed him to this place. He took this point, and then the elder died. And he's not aware of anybody in the village who has that knowledge anymore. So, of course, we collected other examples. This is an example of a trap from eastern DRC adapted to catch chimps and baboon. The communities are monitoring chimpanzee nests, but it's a very basic information because they are volunteers, so then, they're not working for GGI. So here is, for example, a chimp nest collected outside Gombe National Park on the village land. But we are working with partners in places like in Eastern DRC, where we're trying to explore how these devices can be used to do, like, say, distance surveys and do actually full scientific surveys for both chimps and gorillas. As I said before, what is powerful about this method is that the data goes into the cloud. And once in the cloud, you can do incredible things with it. First of all, you can overlay high-resolution satellite imagery. This is an image collected by Digital Globe, which in the past I had to always travel with like 5, 6 hard drives, and it's really difficult to access this imagery. Once it's in the cloud, it's just incredible. You just zoom in and zoom out. It's like Google Earth. And why this is important is because it allows you to unlock the information. And actually what you see here is a mining site in the middle of nowhere south of Micro. Here you go. And you can, because it's in the cloud, you not only can look at the imagery, you can run algorithms such as simple image classification algorithms like here. And also because there is all this Landsat imagery collected, you don't have to store it in your account. You can just access it from the common database. So you can actually see that this site, how this site grew up over the years. The information is not high resolution, but you can combine it with the temporal resolution of the Landsat imagery. Finally, an important revolution which has been happening over the last couple of years is the advances in remote sensing to do global land cover maps. In 1994, the best land cover map of the entire world was at 111 kilometers resolution. We have now in 2012 30-meter resolution coverage for the entire world. So GGI has been working with our partners at the University of Maryland to explore how we can extract useful information to leverage our conservation efforts in Africa. So the reason why this is important is because until now, each of us have been using this methodology to classify our own project areas, image by image. Often they have been done in different methodologies and systems. We cannot combine them. This is one snapshot per year or twice per year of this variable. In this case, is annual tree cover. And here you can see annual tree cover height for the entire chimpanzee range in Africa at 30-meter resolution, still valuable for the project area. So we're exploring at what extent we can use this imagery, which will be available every year starting 2000, to develop maybe an index to monitor chimpanzee habitat health in such a way that we can communicate what's happening to the chimp habitat so my mom can understand as well. And now the final platform which I want to show you, it's something, how this type of information can be connected to actually with decisions. This is the Global Forest Watch. And this is a new platform which we are part of, developed, led by World Resources Institute. But this platform would allow different remote sensing groups to bring the satellite imagery and classifications into under one platform. So you as a user can choose which one best matches your needs. In this case, I'm going to show you an potential application of deforestation alerts. So here's Uganda. The deforestation alerts collected from MODIS satellite at 250-meter resolution are shown in red, overlaid with chimpanzee range in Uganda. I'm going to zoom into an area which we work with private forest owners between Budgoma and Budongo. So here is the alerts, here is the private forest owners mapped by communities themselves with the smartphone and tablets. And this is associations which have been set up in order to coordinate and prepare them for RED, in case that the RED is possible. And this is a riverine forest, how it looked in 2008, and this is how it looked in 2011 at high resolution imagery. If you overlay with deforestation alerts, which are global, at 30-meter resolution, you see that there is quite an interesting match. And because we have the data collected with mobile devices, you know who the forest owners are, you can have the pictures, and this information, I don't want to say useless, but GGI is not a major stakeholder in Uganda, but we can definitely facilitate access to this information and empower this forest owner association, which all the private forest owners, which are part of it, sign that they will protect the forest, and then send somebody with a tablet or smartphone to actually validate if this is correct. There are in some cases it will be correct, in some cases not. And that data, because it goes back to the cloud, can inform remote sensing scientists to improve and upgrade their models. So it's really an amazing opportunity that we all can work from the same hard drive. My final story, it's very quickly, is that when I was a PhD student at the University of Minnesota, I had a chance to work with Takari, a GGI community-based conservation project, and bring this high-resolution imagery to 5 communities. And we quickly looked at this village forest reserve in Zasha village, and you can see it's a forest surrounded by deforestation, but it doesn't tell you why. And we did participatory mapping, we bring this, we get their perspectives, and sure enough, there are sacred sites around this forest reserve. So for example, this is an important island for the fishermen. It's a sacred site. This tree is another sacred site. And then the third one is on the top of the hill. So I think it's very important to remember that as we are using this imagery and technology, the reason why that forest is protected is not because they had good maps and high-resolution imagery and they understood the value in terms of science of this project, but because that forest was somehow in their hearts. You know, they cared about it, was part of their value system. And I'd like to end with this quote from Little Prince that we shouldn't forget that often important things cannot be seen, and we always have to tend to unlock the information, the values which are hidden in this imagery, and it's provided to us as a new glimpse with this technology to this landscapes. Thank you.
Thank you very much, Lillian. And I just wanted to hear from each of you what sort of synergies in your work you can see, and just quickly get your comment on that, James, that offer.
Yeah, I mean, from my perspective on the ground every day, I think the development of the drone technology would come in so handy for us. We see quite a big difference between our rehabilitated females and obviously the males in terms of ranging. And most of our females tend to develop quite stable home ranges within around about 6 months or so. With some of the males, particularly the sub-adult males, we have one particular individual, his name's Oscar, he's 13 years old, and he's very incredibly difficult to follow day by day on the ground. Essentially remembering we're trying to follow behind him with parangs, and he's just traveling very fast on the ground. On numerous occasions, he returned to our research camp, and he actually tried to enter a plantation to the east of our release site as well. And we kept having to recapture him and then re-release him in a core area of the release site. And there was one particular instance, it happened 2 or 3 times, but then he started heading east towards a more core area within Tabin, and he was, by that point, way outside of the range of the telemetry implants. And so we kind of took the decision, okay, we can't continue, we can't sleep in the forest and keep going deeper and deeper and deeper. You're on your own, good luck, mate, you know. So anyway, as it was, I received a phone call from the wildlife department around about 3 weeks later, saying that there was a sighting of an orangutan that wasn't particularly scared of the humans that were surrounding him by that point. And my heart kind of sunk a little bit at that point. And so anyway, we went around. It was about a 4-hour journey to go round to the northern part of Tabin. And lo and behold, there was Oscar in a plantation surrounded by a bunch of people with a tray of rice and scrambled eggs and a shrimp. And anyway, we managed to recapture him, and then at that point we sent him back for medical screening back at the rehab center at that point, because we weren't sure of the level of human contact he may have encountered during that period, because it was 10 days before they even called the wildlife department. But anyway, the point being, if we had a more advanced drone system, as soon as the orangs that we're releasing went out of our feasible tracking range, it would be fantastic to have something that would be able to go up there and tell us where they're headed, particularly the younger males who range so far. And then we could proactively anticipate any potential human-wildlife conflict around the release site. So I think I'm really excited to see where the drone technology is going to take us in the future. Presumably, Serge, you've got something to add to that? Sorry to volunteer you like that.
No, that's fine. No, sure. It's something we would love to develop, and we did a few tests of how that would work, and we hope, depends as always or often on funding, but we hope to get this done somewhere in the next year if we can find the right people to help with it. But there are lots of enthusiastic people, and that's one of the things that I found really fascinating with this drone project. There's people from all over the world that write us that want to help and that have all kinds of interesting technology backgrounds or can help with making the frames, etc. So there's an enormous amount of people out there willing to help with conservation, which is really fascinating and great. And it's to some extent an untapped resource. I know that, for instance, Lillian is looking into citizen science as well, and that's, I think, again, something very powerful that we can use technology for. So, for instance, what I would also like to see is that the images that we take with these drones also go into the cloud and then can be part of sort of an analytical framework to look at habitat chains, etc., and be linked to things that Lillian is doing.
Yes, absolutely.
I just want to add that drones will not replace high-resolution imagery, but a very important instrument to fill the gaps between the ground and the high-resolution imagery. We have a situation just this year where we had an agreement to collect every 3 years high-resolution imagery over Gombe and Greater Gombe ecosystem. And in June was cloudy, and in July was cloudy, and August was cloudy, so we missed all our windows of acquisition. Likely, another satellite collected the imagery in June, so we still can do our analysis. But if we had a drone, we would be much better equipped to deal with cloud coverage. A drone will be also much more participatory, we think, to bring to the community and together launch it and together monitor how they did, let's say, comparing to last year. So we feel that it would be more participatory than bringing a satellite image which is already printed on a paper map.
And Rich, your comments on that, and participation is a big emphasis of your work with the park rangers, obviously.
No, absolutely, and certainly from both Serge and Lillian's presentation, there were a number of things that would be quite easily integrated into SMART and very useful. I think OD was something Lillian and I have already talked about, but allowing people to collect data with ODK and have that feed into SMART. Google Imagery, making that available in SMART would be very useful. And I think the idea of using drones not just for collecting imagery and looking at habitat loss or identifying poaching, but using them as a communications platform so that people in the field can be communicating directly with headquarters. In most of, or a lot of the places in Central and West Africa where these guys are working, there's no cell phone network, there's no, they don't have satellite phones. Once they're in the field, they're more or less on their own. And given how serious a lot of poaching is getting these days, it's an issue that they don't have the ability to call for backup or even relay the fact that they need more food or somebody slipped and broke their leg or something like that. So using drones as a platform for them to be able to communicate back to headquarters would be incredibly useful.
Thank you. I'm going to open it up to questions. Is that Damien over there?
Yeah, that's right. Thank you. Damien Mander with the International Anti-Poaching Foundation. Guys, thanks very much for your comments up there. It frustrates me, having spent a lot of time in conflict zones around the world, to see the full might of the military muscle wind up and all the resources that get thrown into that side of things. And as an industry, for conservationists, not just here with Great Apes, but everyone around the world who's trying to save these animals and these environmental areas, I couldn't think of a more restrictive industry in terms of the areas we have to cover and the funding we have. And I find that we're constantly trying to reinvent things, and I'm guilty of it myself, reinvent things that have not only been developed by the military but have been superseded and are generally sitting in warehouses around the world gathering dust. And it's not the fact that we just can't go and buy those things off the shelf. We have to go and build them ourselves because they're just not going to give them to us. I'm thinking, with all the constant connections now that's being made to human trafficking and terrorism networks and wildlife trafficking, and all these lobby groups that are now going on and the task groups that are being formed, can some of the leaders within the conservation industry not get together and start pushing governments to give us access to the stuff that is sitting in those warehouses around the world? And I promise you, the stuff is there, and it is the tools we need to win this war.
It's really interesting that, because actually the Cineflex aerial camera that we have been using in documentaries for many years, gyro-stabilized platform, was of course developed by the military and was an absolute nightmare for us in the early years of filming, because trying to get it in and out of different countries was a real issue. So yeah, I can identify with that, and I wish there was a way that we could access all the types of drones that have been developed by the military are way ahead of what we're looking at. Any other comments or questions? Over there.
Hi, Ralph Scar with the Forest Campaign at Greenpeace. A question for Serge. Increasingly, companies who have high-risk commodities like palm oil or pulp and paper in their supply chains are being motivated by NGO campaigns to deal with those issues. And I'm wondering if you're getting much interest from the private sector. They have lots of resources. They're scratching their heads about how to ensure that their supply chains are free of some of what we've been talking about at this conference. And I think funding would be made available for key suppliers to help patrol plantation areas or concession areas, and to make order out of some of the chaos there?
Yes, well, we've been getting some interest from oil palm plantations that are interested to have their areas mapped. One of the slides I showed was an oil palm plantation in Sabah that asked one of our colleagues in Sabah to map their area. But of course, what we would like to see is, I think what you're suggesting, to see that companies that want to stick to certain sustainability or certification guidelines have their areas mapped every 6 months or something, so we can check, is that riverine forest still there? Did they cross into protected areas or not? And I think that kind of level of monitoring and transparency should become part of the certification processes. And that will indeed free up money to do some of the development potentially as well.
My question is for Rich. Rich, at the last COP of CITES, the Mike program was going to the end. And now I remember that when Mike was explaining the new transitional plan, SMART was recommended, but there was a restriction for us, who have in the different site of Mike, because this was only restricted to some site of Mike, like the one in Nigeria. I would like that you can probably elaborate more about the issue or constraint that we have, because we cannot, for example, use the SMART system for the monitoring in our site.
Well, I know Mike is part of the SMART partnership, and my understanding is that they have chosen 2 sites per elephant range country for deploying SMART. That doesn't mean that individual sites aren't allowed or able to use SMART. SMART is free software. It's available on the web. You can go to www.smartconservationsoftware.org and download it for free. There are training materials there, examples, basically everything you need to set up a SMART installation. So Mike may not be providing funding for all the elephant sites across Africa to deploy SMART, but SMART is absolutely available for anybody to use anywhere. So Mike may not be providing that funding, but SMART is available.
Hi, a couple of comments and a couple questions here. One is, Serge, I'd like to ask about the drone and the remote cameras. You're close to what we've been thinking about for years now, real-time information being beamed back from the field to people who can act on it immediately. I'm wondering, with the drones, have you been able to figure out how they can upload that information? The canopy coverage, does that have an impact on uploading that information? And how often these drones can fly into those areas to upload such information, where you might have a photo of a poacher that could be beamed up to the drone and sent back and acted upon. But that would require, the other aspect of it is analyzing all of those images to tease apart, is that a person who's a farmer or a poacher or a person who could be in that area? And the second question is for Rich. With regards to the mobile devices, one of the problems is battery life in these areas with these teams. It's a basic thing, but battery life on most of those things has a limited amount of time, and that's a stumbling block. And I was wondering if anybody's working on that technology.
So in terms of having photos from camera traps go up to the drone, that technology is basically there. We want to test it out and get some cameras that can do this, but we don't have funding for it, and the company that we asked for a few test cameras, Buckeye, didn't provide those cameras, so that was kind of disappointing. So we're a little bit stuck there. But in terms of getting photos or video back from a flying drone to the ground, the technology is there, as Damien also says, but it's fairly costly still, and you need to have antenna systems above the canopy, or do it in other ways, digitally maybe. I think that the recognition part, to recognize a human that's not so difficult. There's lots of people working on that kind of object recognition from video and photos. To distinguish a farmer from a poacher, that would be probably more challenging. And to quickly come back to Damien's suggestion, that same question was asked at the wildlife crime meeting in DC last year, and the answer of the US Army was that military surplus can only go to other military forces, as I'm sure you know. So that was somewhat of a stumble block. It has to be mill to mill, as they say, instead of going to conservation groups. And it needs to then also be higher up in their operational procedures, etc. So I think that there seems to be some willingness, but it will still then go to military forces within other countries and not to other groups. So that's what at least was the answer that they gave us then.
I just had a question before we go to Rich, which was something we were talking about in terms of if you do photograph poachers from a UAV, is that admissible as evidence?
I think that would depend on the country where you would be. I don't know. And that would have to be tested. I'm quite sure that most legal systems will not have an answer to that, probably because it's not something that is happening yet. So I'm not sure. It's one of these things that we need to test out. And I think Ian also brought it up in his presentation, photos taken from the air, and to get that as legal evidence in court, it takes a few steps. And all the images that you take with the drones are geotagged, so you know where they are taken. But still, I'm not sure whether that would hold up as evidence in court, because you can also geotag photos later on yourself.
Right.
So it's
interesting to test.
Yeah.
Rich, sorry, your answer.
Yeah, sure. No, I mean, anytime you're using any kind of electronics in the field, power is always an issue. With these kinds of devices, usually our patrols have been getting about a week, sometimes as much as 10 days out of a single charge, because they do have quite large batteries in them. We're field testing right now some new rugged Android phones, which have relatively large batteries, and I think don't use as much power as these do, so we're hopeful that those will have pretty good longevity. But ultimately, you do need to have a source of power, and sometimes that can just be as simple as a $300 generator. At the Imbe Mountains, the site I mentioned here, all the ranger camps have a small generator, and at the night, if the devices run down, they run the generator and they charge it, and it's an added benefit for the rangers too, because they have light and they can charge other stuff as well. There are good solar systems, portable solar systems that are increasingly available that come paired with lead acid or similar batteries, so that the devices can be out during the day. The battery is charging while the teams are out, and then when you come back to camp in the evening and the sun goes down, you can charge off the stored power. So there are ways around it. Some are more elegant than others, but it's certainly possible. I mean, we have all our teams using these, and we've been able to deal with the power issue.
Yeah, this is a question for Serge. Serge, I was just wondering, what kind of permissions have you needed in the various sites that you've worked at to use drones, and do you see that being a challenge at all in areas that might be in conflict or have military, in terms of getting permission to be able to use drones?
So far, it hasn't been a problem in most of the areas where we work. I mean, the local authorities are mostly supportive. In Nepal, we work closely together with the army, because the army protects the national park, so there it's very easy. They just arrange the permission. Often we fly quite low and over forest areas, so there's no problems with villages, for instance. But I imagine that if you start flying over sensitive areas, that it might be more difficult to get permission. And when you start flying with systems that can fly longer and higher and are more advanced, I'm sure that you would need to get permission as well, and that it might get more complicated. So I foresee that in some areas that especially where there's military conflicts, like in areas where some of the guerrillas are, I can see that potentially is a real problem, because I'm quite sure that the military would not appreciate us flying over them and taking pictures.
We have been testing last year 2 of Serge's drones in Tanzania and in Kigoma region in order to try to see if we can detect chimpanzee nests on the steep slope in Miombo woodland during the dry season. And the Tanzanian local government didn't require us to do any permits, but they did ask how high it flies, if it will be interfering with airplanes. And that's it. And rest, maybe it's also an indicator of our good relationship with the local government there, because we have been working in the region since 1994. But it was very straightforward for us to test these drones.
I was just wondering, obviously, if you can access all this technology, clearly so can logging companies, mining companies, poachers. Is there much evidence that they are also getting their hands on the kinds of technologies that you're using for conservation?
Well, I think certainly the larger logging and mining companies are way ahead of us in terms of their use of technology. They're already using as sophisticated or more sophisticated imagery. They have access, because of the budgets of some of these projects, they can afford to rent or own. They own a helicopter and fly helimag surveys of the forest or their mining site, or have a whole team of geostatisticians working on what's the best way to get the ore out or get the logs out or whatever. So I think we're playing catch up in a lot of different ways. I mean, Damien earlier mentioned the use by poachers of night vision goggles and things like that. I don't know of any ranger force in Central Africa that's using night vision goggles, and most of what these extractive industries or poachers are going to use is available anyway. And when everything that we're using is really already available, we're just putting it to a different use.
But this said, I think it's important to ask ourselves, why especially with this tendency now to open the information, because again, in order to change people's behavior, we really have to engage them, and this means opening up some of this data and information to the public. And we decided, for example, in that dynamic map, not to show actually the location of chimpanzees and call them conservation targets. It doesn't mean that but this is just to make sure that people don't know exactly what the chimpanzees are.
That's a difficult
it's a difficult balance between,
So I think we're running out of time, and I just wanted to ask each of our fantastic speakers today if there were 2 things that they could ask for, that they'd need or want to happen to really move their projects forward. What would they be? I'll start with Rich.
I think the involvement of both technology companies and individuals, like was already mentioned, who would be willing to commit their time and resources to help develop some of this stuff. Possible exception of Lillian, none of us are professionals at doing this kind of thing, where we've picked them all up as tools to deal with conservation problems. And then the other is to provide the rangers working on the ground with the tools broadly defined that they need to do their jobs. I mean, that goes, and that runs the gamut from boots and uniforms and being properly paid to being supervised by managers and directors of protected areas who aren't corrupt, so that the dangerous job that they're doing on a daily basis is fully supported.
Pretty much as I said in my presentation, we need a lot more investment in this implant technology if we're going to move it forward and if we're actually going to overcome some of the issues that we've been having with it. And as I said, that's going to involve many, many people in this. We need to speak to surgeons. We need to talk about alternative implantation sites. We need to talk about engineers. Talk to engineers. We need to be constantly communicating with people in the field that are using this as well. And along with that, obviously, money. We need significant financial investment to move these forward. And I suppose number 2 would be drones. I'm really excited by this, and I see significant potential for everyone who's conducting post-release monitoring.
All right, thank you. What I think would be really useful is to try to establish maybe a working group or something like that, where we work together to see what kind of technologies we really need and how to integrate all of this, so that we can develop a package instead of us developing some of the drone technology, you developing some of the smart technology, Lillian doing some things, James doing some things. If we can all have a working group in which we say, okay, we need this, it needs to communicate with that, we need that, it needs to communicate with that, and that would really help. And then, as a second step, try to make it as simple as possible so that people on the ground can use it. Because if we make it highly complicated or highly expensive, it's going to be so much more difficult to implement it in all the different areas where we're working. And we're working in a lot of different areas. If I look at the audience here, I mean, there's 23 countries, many areas within one country to supply all those sites with sort of the technology, etc., that is needed there is quite a tall order if it's very complicated.
I think there is a great need to step back a little bit and ask the question, what we're trying to achieve. And to me, at the Jane Goodall Institute, we're very clear that our mission is to focus on removing or eliminating the threats, the most important threats for the chimpanzees. This means that once this is identified, the question is how you scale up. Because we have been using this advanced technology, very innovative, which have huge potential to be really scale up. But technology is good, but I can tell you that from 52 villages which we work in Tanzania, each village needed its own approach. Different government, different people, different leadership. So this is something which it means, kind of going back to your last slide, that you need people on the ground. I would like to see how we can think about how all of us in this room, how some of these technologies can be used to leverage your work on the ground, how these technologies can actually help you, who understand the complexities, who understand the decision makers, understand how to reach today hearts and change their behavior. Going back again to the idea that we have to change people's behavior, we have to reach to their hearts. I think this is the most important part. Because otherwise it's going to be just another fancy tool and a toy.
Yeah, fantastic summary. Well, can we say officially there's a working group that's begun? Good outcome. I think you'll agree they're already obviously doing great work. And it sounds like you already want to have a dialogue with them, so maybe that can continue. And if anyone's got good contacts with technology who can help crack some of these problems, I think the least we can do is start making contacts and all pulling together. Thank you very much for coming today.